All right, here we go. Practice set A, number 2, because there were 2 of them, so here's number 2. Here we go. Interval of convergence for the series here is one of these values. So we're again doing interval convergence, I think, ratio test. So let's write that out. I get limit as n goes to infinity of 3x minus 2 to the n plus 3, because I add 1 to this, over n plus 1 to the 5 halves times n to the 5 halves over 3x minus 2 to the n plus 2. Great. I'm going to try to simplify some things, particularly these pieces here. So this becomes limit as n goes to infinity of the absolute value of 3x minus 2 over 1 times n to the 5 halves over n plus 1 to the 5 halves. I have this limit like we did in the first practice set. The limit of this will be 1, so my limit ends up equaling absolute value of 3x minus 2. To converge, we want that to be less than 1. From there, 3x minus 2 is less than 1. Let me rewrite that. 3x minus 2 is less than 1 or greater than negative 1. Add the 2 to both sides, I get 1 less than 3x less than 3 divided by 3. And we get 1/3 is less than x, which is less than 1. Good news, I see a bunch of answer choices that match close to that, so now we got to check each endpoint. So here we go, make a quick cheat chart, series at the left endpoint, series at the right endpoint. Plug in 1/3, I get 3 times 1/3, that is 1 minus 2, that's negative 1, so I get negative 1 to the n plus 2 over n to the 5 halves. Right side, I plug in 1, 3 times 1 minus 2 is 1 to the n plus 2, all over n to the 5 halves. This one's alternating. I take the limit of 1 over n to the 5 halves. That equals 0. It's alternating. Limit 0. This side converges. Right side, this is not alternating. So I got to use my p-series test. P equals 5 halves. That is greater than 1. This side also converges. Looking at these, I update my inequality. Looking for this answer choice, I see that here with both of those, answer is D. Got that. On to number 2. The Maclaurin series expansion of 1 over 1 plus x squared is one of these answer choices. So something I need to keep in mind is I could make this from scratch. That would take a long time. But this looks very similar to 1 over 1 minus x. What did I replace the x with though? 1 over 1 minus something, that would have to be negative x squared, like this. So then the Maclaurin series expansion of this would be, well, I know for this it's 1 plus x squared plus x to the 3rd. Everywhere I see an x, replace with a negative x squared. Here we go, 1 plus negative x squared plus negative x squared squared plus negative x squared to the 3rd. There we go. Now we got to simplify. We get 1 minus x squared plus x to the 4th minus x, 2 times 3, that's 6. Looking for this answer choice here. I have a bunch of denominators there, not going to have those. This one's not alternating. Answer choice is B. Make sure you got that. 2 for 2. Here we go. On to number 3. So let p of x be the third polynomial for the function about x equals 0. What is the value of the third derivative? This is a new question that challenges your really deep understanding of Taylor polynomials. Derivative of f, that would be included in producing the third degree term. So negative 5x to the 3rd, that would equal the third derivative at 0 over 3 factorial times x, it was centered at 0, times x to the 3. Then from here, I can back solve for what I'm interested in, and I can get negative 5 x to the 3rds cancel, bring the 3 factorial up, equals the third derivative at 0. This becomes negative 5 times 6 equals the third derivative at 0. So f, the third derivative, equals negative 3. So that is answer choice A. Pro tip on this question. Negative 5 is there as a distractor, and you would pick that if you forgot the 3 factorial down here. So make sure you don't forget that. Also, If you thought this was just 3, that would lead you to answer choice B, which would also be incorrect. So be careful of those distractor answers there. Then there's a few other things going on here that really don't matter. So 3 for 3. See you in the next video for the rest of this practice set.